So today we're going to learn about the history of the Earth, or sometimes what's referred to as historical geology. When we're talking about the history of the Earth, we can't use a regular timeline or time scale because the events that have shaped the Earth span a period going back to 4.6 billion years ago. And so in order to discuss and identify events, geologists have created what's called the geologic timescale, and it is a chronological sequence of events in the Earth's history. It's a timeline, but it's not divided up based on a decade or a century or a millennial. It's divided into units based on major changes in life forms. Throughout Earth's history, life has become more complex since the beginning. When we break it down into the timeline, the largest periods of time are referred to as eons, then an era, then a period, then an epoch or epoch. If we start at the bottom, we can see that the Precambrian was the largest time period, stretching from 4.6 billion years ago to 544 million years ago. There were no life forms recorded during this time period. The Paleozoic is a time from paleo referring to ancient that stretches from 544 million years ago to 248 million years ago, and invertebrates were the dominant life form during that time period. The Mesozoic, many people are familiar with, based on reptiles being the dominant life form. And with reptiles, that also includes our dinosaurs. Again, stretching from 248 million years ago to 65 million years ago. And lastly, we enter what we are currently in, which is the Cenozoic time period. Mammals are the dominant life form, and the Cenozoic began approximately 65 million years ago. You may ask why do we have these different time periods? Why do different life forms become dominant? And really, starting with the Paleozoic, the end of the Paleozoic was marked by a mass extinction. Eras end when a mass extinction leads to a change in the dominant life form. The most recent mass extinction was during the Mesozoic. That was when 90% of all life disappeared, approximately 65 million years ago. The evidence for this happening is actually this really thin layer of iridium in the rock layers. And this iridium layer is found throughout the world, all during the same, all at the same time period. And iridium is an element that is not found naturally on Earth, but is commonly found in meteorites. And so the conclusion, after many years of scientific investigations, is that a meteorite struck off the coast of the Yucatan Peninsula, just off of the eastern edge of Mexico. And this meteorite had three different ways that it led to the dinosaurs and all other 90% of all other life disappearing. One was the direct impact. Animals, plants, species were killed instantly by fire or smoke. The second way was a shock wave that would have blasted through much of the, underlying, or the areas within hundreds of miles. But most importantly, what happened was that dust from the impact blocked out the sunlight. And that is referred to as the effects are sometimes referred to as a nuclear winter, meaning that without the dust in the atmosphere blocks out the sunlight, and without the sunlight, and again, this is for thousands of years that the sun is blocked out, and therefore life begins to perish. So that's a brief history of what the time scale looks like. We're going to talk now for a few minutes about the different ways that geologists establish when certain events happened. There are two main methods that are used. One of them is a method that is referred to as relative dating, and we're going to start with that. Relative dating is putting events in order and sequencing them. It's based on your position in the rock layer. Relative dating is an example is by saying that something is younger or older. Relative dating does not give a specific age, a numeric value. It simply refers to being younger or older. The three methods for relative dating are that there are three geologic laws. Whoops, sorry. Oh, I can't go backwards. The three geologic laws, since I clicked by accident, are the first law is going to be the law of superposition. The law of superposition states that in a sequence of rocks, the youngest rock layer is on top and the oldest is on the bottom. In looking at this picture on the bottom left, then, therefore, what is referred to as the Kaibab limestone would be the youngest because it is on top. And the Hermit shale would be older because it is on the bottom. A second geologic law that we look at is the law of cross-cutting relationships. And this law states that when a fault cuts through or when magma intrudes, the fault or the intrusion is younger. So in the example on the left-hand side, the order of oldest to youngest would be layer 1, layer 2, then layer 3, layer 4, and then finally the dike that cuts through it all is the youngest. We also have the law of original horizontality, which says that all rock layers are deposited in a horizontal position. If the layers are not horizontal, some sort of tectonic force caused the change. And so in terms of the image on the right-hand side, since we can see that these rock layers have all been curved, then we know that that curving happened after they were deposited. So that's a brief overview of the relative dating methods. There is also a method that is referred to as absolute dating. This determines the actual or numeric value for events. For example, you could say 35 years old versus 17 years old. The method of calculating absolute age is accomplished through what is referred to as radioactive decay, which is the process of radioactive elements forming new elements. Half-life is the amount of time it takes for half of the parent isotope to become the daughter. So in this image here, on the left, the green column, after one half-life, we have 50% blue, 50% green. After two half-lives, we have 25% green and 75% blue. After three half-lives, we're down to 12.5% green and 87.5% blue. There are frequently used parent and daughter isotopes used to calculate age. One of the most well-known is the uranium-238 to lead-206. This takes place, the change of half of the uranium-238 into lead-206 takes 4.5 billion years. There is also a uranium-235 to lead-207, rubidium to strontium, potassium to argon, and each one of these has a specific amount of time that it takes, that half-life, for half of the parent to become the daughter. So based on scientists comparing the percentage or the ratio of daughter product to parent product, they are able to calculate the age. That's all for today.